Now that we have reminded ourselves what direct variation is, let's go through some different types of questions that you might be. You will be asked to find the constant of variation k, and you also might even be asked to find the equation. So I popped on both of those on the screen for you that we got from the last note card 114. You need to know both of these when it comes to direct variation, that if we are talking about a direct relationship, a direct variation, a direct proportion, the constant of variation equals the y value over the x value. That's one of the rules. And if you're trying to write the equation, once you find a constant, it'll be a number. Once you find that number k, you plug it back in right here and you have y equals whatever k is. So 5, 11, 1/2 times x. Okay, so right here in this example, it says, given that the set of ordered pairs below represents a direct variation, what is the constant of variation k, and what is the equation to represent the relationship? Okay, so I'm back to my document camera. All right, so what do we need to do? Well, we know that k equals y over x. So if I need to find the constant, and I know that this is a direct relationship, I just have to pick one of the ordered pairs and do y divided by x. So I'm going to pick this one. K equals 4 divided by 1, that equals 4. So k is 4. Now, I just want to double check myself here that would work out with each of the other ones, just to make sure. Did you get it done? Almost. So it'd be k equals 8 over 2, which equals 4. Yay. This one, k would equal 12 over 3, which equals 4. Yay. This one, k would equal 16 over 4, which equals 4. Yay. So it does work out. K equals 4. And the next part of this, they want the equation. So remember, once you know the constant, the equation with direct variation is y equals k times x. So your equation on this one would just be y equals 4 times x, meaning if you know that x is 3, could you figure out y? Well, yeah, you plug it in, you get y would equal 4 times 3, which is 12, okay, which we knew right here. But what if x was 12? You would do y equals 4 times 12, y equals 48. So there's your constant, and there's your equation. Now let's go and look at the other one. The other one on the right here is a table. And so it's still information. It's still like ordered pairs. It's just in tabular form. So now we need to find the constant and the equation to represent the relationship. All right, so I've taken the table, I've put it here. Boom, 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 boom. And we need to find the constant. So remember, we're in direct variation. So the constant equals y over x. And you can just pick. I'm just going to use this first one. So the constant would equal negative 8 over negative 12. And I'm going to reduce that. The negatives would go away. Divide by 4. You get k is 2/3. The constant is 2/3. So to answer the first question, k is 2/3. And you can double check yourself here. Negative 4 over negative 6 would be 2/3. 0 over 0, we can't really even use that one. So we can just ignore that because it's indeterminate form. And then 2/3, okay? So we've got k equals 2/3. Now the equation is y equals kx. That's something you need to remember. So it is y equals 2/3 x. And there you go. All right, so here all of it is back on this slide. So finish up note card 115.